Climate change is urging us to drastically minimize the use of fossil energy. The industry has little alternatives. Currently, the industry uses coal, oil, and gas as feedstock and fuel in their processes to develop base chemicals for further development into necessary carbon-based compounds and materials. Our chemical sector that delivers these base chemicals will have to replace its traditional raw materials and energy sources with sustainable ones as soon as possible if we want to become CO2 neutral by 2050. E-Refinery is exploring possibilities for the radical transformation of the chemical industry. It focuses on the electrochemical conversion of water, air, and biomass into fuels and bulk chemical using sustainable electricity. E-Refinery aims at two technologies. 1. The indirect route towards chemicals and fuels via green hydrogen. With H2 and carbon molecules from air or biomass, it is possible to make base chemicals and fuels using several steps of thermochemical reaction processes. The indirect route requires high temperatures and pressures. 2. The direct route where CO2 and water is directly converted into chemicals and fuels. The latter route is very challenging, but could prove to be more efficient in the future. E-Refinery research combines various disciplines involving the many time and length scales of the conversion process. Each of these scales has its own challenges and its own complexities. As you move from the nanometer scale towards the kilometer scale, this requires the combined expertise of scientists and engineers, such as electrical, chemical, and mechanical engineers, process and reactor engineers, and system integrators. Our approach will develop the necessary technology breakthroughs faster than when the problem is addressed step by step from scientific understanding to technological development of upscaled chemical processes. The e-refinery concept is not only used to develop sustainable base chemicals for production of materials and products, but also for the use as a medium for long-term energy storage of intermittent renewable energy sources. Furthermore, the developed e-refinery fuels can serve as an alternative energy source in the intensive industry, but also for long-distance transport, for example, the aviation industry. To facilitate the upscaling and industrial uptake of electrochemical conversion technologies replacing fossil energy, e-Refinery has set itself the ambitious goal to design and construct 100 kilowatt direct and indirect electrolyzer demonstration systems for the large-scale production of base chemicals. The Netherlands is an energy gateway with a strong innovation and trade culture. E-Refinery technology could become of global relevance. To succeed in this, we welcome partners from industry, government, and academia to aid in this challenge. Contact us if you'd like to cooperate with us.